All right, number 15 is another cone problem right here. And they're giving us a couple derivatives. We want to come up with the rate at which the volume is changing. So I think the direction in which you draw this cone doesn't really matter, but we've got a cone that looks maybe something like this, and the entire cone is growing is what it says. So what's going on right here, guys? We've got our radius up here on the top, and then we've got our height coming right down here on the bottom. And they're not actually saying that the radius is 10 for the entire cone and the height is 20. It looks like the cone is probably bigger than that. However, it's that ratio of height and radius that really matters. So I'm going to go ahead and put a 10. I mean, really, technically, you could put like a 10x right there and then a 20x, but you'll see in just a second why that matters, or that doesn't matter, excuse me. So what derivatives were we given in this problem right here? They're telling us that both the radius r and the height h are changing at a rate of 2 centimeters per second. So they're telling us that dr dt and dh dt are both the same, and they're both equal to 2 centimeters per second. Okay, gotcha. Now that I think about that, I'm not sure that I needed to do what I did here. Anyway, let's get working on this. The derivative we want to know, how fast is the volume of the cone increasing? So we want dv dt at the moment when r equals 10 and when h is equal to 20. So I think I could have done that little ratio trick right here that I just did in problem number, what was that, 13, guys? But I don't actually think it's necessary. All right, I'm going to look for an equation now that relates r and h and v. And that's going to be the formula for volume of a cone, 1/3 times pi times r squared and then multiplied by the h. Now, there's 3 variables within that formula right here, but I already know the values of the derivatives of 2 of them, dr dt and dh dt. That's the one that I'm looking for. So I think we can go ahead and differentiate this just the way it's written. So we'll do the derivative of volume with respect to t is equal to, and in a case like this, I would probably use the constant multiple rule and just say, look, if my function begins with a constant, 1/3 pi or pi over 3, I'd probably just start my derivative with that same constant, 1/3 pi, and now start worrying about the derivative of r squared times h. Now, the big kicker to this problem, guys, is that we have 2 different variables that are being multiplied by one another. That means we are going to need the product rule in order to figure out that derivative. So let's do that. First factor is r squared, and we'll multiply that by the derivative of the second, which is dh dt. We will add to that then the second factor, which is h, multiplied by the derivative of the first, which is going to be a 2r, and then there's going to be a dr dt that comes at the end of all that. So that's what I would expect was the biggest problem that you guys might have had if you didn't get the right answer for number 15 when you tried it on your own. I bet a lot of people forgot that we would need the product rule because we're multiplying 2 different variables together. Okay, so with that, we've got 1, 2, 3. I guess I already counted r, so that would be 4 and then 5 variable quantities. The one we're looking for is dv dt, and that's already isolated over here on the left-hand side. That means we better know the values, time specific or constant, of r, dh dt, h, and dr dt. And I think I've got all of that, guys. Here's the value of dh dt and dr dt. This is the time-specific value of r. Here's the time-specific value of h. I think we have everything we need here. So this is going to be a 1/3 pi. And then in parentheses now, our radius at this moment is going to be, let me get rid of those stupid x's I put there. The radius was 10. So I'll square that and get a 100, and then multiplied by dh dt, which is right here, dh dt is 2, plus 2 times the radius at the moment in question is 10, the height at the moment in question is 20, and dr dt is given to me on this line here as well. That is a 2 also. So we're actually very close to being done with this problem. Let me slide things around just a little bit, and let's see what we can do here. So dv dt is going to be a 1/3 pi, and then let's see what we've got. 100 times 2 is going to be a 200 right there. Ooh, let's see. 10 times 20 is 200, 400, 800 right there for the second one, and we're adding those two together. Well, that's convenient. 200 plus 800 is 1,000, which unfortunately is not divisible by 3. So I think our best answer here is 1,000 over 3 multiplied by pi, or of course you could put the pi on the top of that fraction as well if you wanted. And if you want to go to your calculator and get a decimal, go right ahead. That's really not necessary. I'm looking at the solutions manual. They have both answers written here. 1,000 pi over 3. We're talking about the derivative of volume. So that would be cubic centimeters per second. Okay, gotcha. They also have it as a decimal, comes out to 1047.20, and I bet we would have liked one more decimal there, but I really don't think that's necessary. I'm going to quit right there and say that that's our answer for problem number 15.